Today's lesson is called Multi-Step Volume Problems. So some problems require you to find multiple volumes and then perform an additional operation, such as adding or subtracting, or possibly would ask you to compare the volumes, such as which one is greater, or some other variation of something where you have to complete more than one step to get to the answer to the problem. So overall, we want to share some strategies to help you be successful when tackling these multi-step volume problems. First, make a picture if one is not given. Sometimes it's really helpful to be able to visualize what's going on in the situation. Don't be judgy of your drawings, just do the best you can. I know these are 3D shapes. Next, you always want to make sure that you write the formula. We have learned a formula for cylinder, cone, and sphere. So once you've made the determination as to which shape you are working with or shapes you are working with, use the appropriate formulas for each one. Check to make sure the unit measures match. Some questions may give you one dimension in inches, but another in feet, or something similar. You have to make sure that your dimensions all match before you plug into the formula to work on finding your answer. Use the picture or keywords to help determine the next operation. So if you're looking at a picture, look at it and say, okay, are there multiple shapes here? Well, I have to find multiple volumes. Should I add or subtract them, etc.? If there is not a picture, look at the keywords in the problem to know what you should be doing as your next operation. And then lastly, check the directions for exact or rounded answers. Make sure if you're rounding, you use those ugly, gross numbers all the way until the very end of the problem. We're going to extra underline that here to make sure we're not rounding until the very end. So again, make sure you're checking directions for exact or rounded. So let's move on to our first example. Example 1 says determine the exact, I'm going to underline that right now, volume of the cone shown below. So exact means I should actually not be doing any rounding. And that means we want to leave pi in our answer if pi ends up being there. Okay, so I'm looking at a cone in front of me. I'm going to go over here on the side and write down the volume formula for a cone, which is 1/3 pi r squared h. Now, looking at that formula, I know if I'm going to find the volume, I need a radius and I need a height. So we need r and h. When I look at my picture, I see this nice vertical line drop down to the base. So I know this is my height, and my height is 6. My radius, however, I'm going to change colors, is currently not labeled with anything. I have no idea how big my radius is. So the R, we are not sure. We don't know that. So over here, I'm going to put a little question mark. That means we have some work to do. So here's why this is a multi-step problem. I need to find the radius first before I can move forward and actually find the volume of my shape. So looking at that picture, I'm hoping that you notice something that we've discussed before. Here's that box that indicates that we actually have, as I'm tracing in blue, a right triangle where we know 2 of the sides and we don't know the third. So that means we actually are going to have to use Pythagorean theorem to find the radius. Now in our picture, remember the longest side, the side across from the right angle, is your hypotenuse. So we know that 9 is C. The height is also a leg, so that's one of our legs, and the radius is our other leg. So in the formula, a squared plus b squared equals c squared of Pythagorean theorem, we know one of the legs is 6. We do not know the other leg, but we know it's going to be our radius. So I'm going to actually switch that to be r squared instead of b. And we know our hypotenuse is 9. So 6 squared is 36. 9 squared is 81. And now we can start to solve this equation. I need to get r by itself. 36 is with it, and addition is happening. The inverse operation of addition would be subtraction. So I'm going to subtract 36 from both sides. So r squared equals 81 take away 36 is actually 45. Now, when we did Pythagorean theorem, we know to take it a step further, we'd actually have to find the square root of r squared and 45 in order to get the actual radius. I'm going to say, let's actually keep this. And why do I want to keep this? Because if I go back and look, I'm going to have to take r and square it anyways, correct? So why square root it if I'm going to turn right back around and square it again? Now, I'll show you the other way too in case that's confusing, but I noticed r squared is in the formula, so I'm just going to stop right there, and I know r squared is 45. So now in my formula, I can do 1/3 pi. The whole value for r squared is 45, and the height is 6. So now if you recall, it said exact. So I'm leaving pi in my answer. I'm not typing pi in the calculator. I'm going to multiply 1/3, 45, and 6. So if I do that, I get 90, and pi stays as part of my answer. So that means my volume is 90 pi. Now, I don't see any units in my picture. I don't see centimeters or meters or anything like that. So we're just going to say units, and because it's volume, it should be cubed. Now, if keeping the r squared was confusing to you, let me show you what you could have done instead. You would have taken and had r squared equals 45. You would have taken the square root and had r equals square root 45, because since it says exact, we shouldn't find the decimal. So then, when you plugged it into your formula, you would have had 1/3 pi. In for r would have been the square root of 45, but then you would have turned right back around and squared it, times 6, which is the height. So you would have just had this step, 1/3 pi. The square root of 45 squared is 45 times 6, and now you can see it looks exactly like what we did above. So if you realize to keep it, great. If you don't, you're still going to be able to get the correct answer. Now for our final example, example 2, we have a circular base of the cone that has a center at C. So you can see down here is the base of a bigger cone. But then you have another circle with center B. So I'm going to do this one in blue. So from there up, you have a second cone. The circle is the base of the smaller cone with a height of AB. So in the blue cone, we've got a height of AB. And along the side, I hope you see that they've shown us the height for the larger cone. 5 and 5 would be a total of 10. So just to label some things that we see. The measurements in the diagram are given in inches, so they didn't label them in the picture, but they're telling us there. And then we have triangle ABD is similar to triangle ACE. So we're going to talk about that more coming up in the year, but I want to show you what that really tells us and how we can quickly figure out some information. So my first suggestion here would be to actually draw a little sketch of each of these cones separately. So if you look at the top, we have the blue cone, to the best of my ability. We have a radius of 2. And according to the side, we have a height, which would be from here and up, of 5. So inside there, you see you have this triangle that ends up having a height of 5 and a base of 2. So if I now draw the larger cone, I have a radius of X. I actually don't know the radius of this cone, but I do know the height here. The height is the entire distance from here to here, so that is a height of 10. Now, if you just look at those two triangles for a second, this one, 2 and 5, the larger one, X and 10. Just looking at the picture, I see that the height of the smaller one was multiplied by 2 to get 10. So we just want to make sure we do the same thing here. So 10 is coming from 5 times 2. So now I can take 2 and also multiply it by 2, the base. And if I do that, that gives me the radius. This is the radius of the larger cone. So just paying attention that this got multiplied by 2, which means this also needs to be multiplied by 2. So now I know in my new picture that that x value is actually a 4. So I'm going to cross that out and make it a 4 instead. So now I have the dimensions that I need. So moving on, I'm going to go down underneath, and it says the smaller cone is removed to create a new object. So we're going to take a look at this picture and see what happened. Well, it looks like if you compare the two pictures, the top cone was chopped off, and now you have this kind of lampshade looking figure. So if I go up and find the larger cone's volume, and then if we're chopping off the top, that means I'm going to take away the volume of the smaller cone. That should leave us with the volume of this new shape that, again, looks very similar to a lampshade. So let's start working through this to figure out what's going on. So here, I'm going to make a little note that the small cone is cut off. Because it's cut off from the top, we are going to have to subtract these volumes to figure out the remaining volume of this unique shape. So I'm going to go back up here, and we're going to start with the larger cone. I know it's a cone, so that's V equals 1/3 pi r squared h. I'm looking for the volume, so I'm going to fill everything else in. 1/3 pi. I now know the radius of the larger cone is 4. I know the height is 10. That is 1/3 pi times 16 times 10. Now here, I changed it into a decimal just to show you that you can. If you want to leave it in terms of pi until you do the work at the very end, that's okay. So that's 167.5516082. And since this is volume, and remember it said it was measured in inches, this is inches cubed. That's the larger cone. Now let's find the volume of the smaller cone. We'll do that down here in this area. So smaller cone. Still the same formula. Volume equals 1/3 pi r squared h. Looking back up, trying to color code here, the blue, the smaller one. Our radius was 2, our height was 5. So we're going to do 1/3 pi. Our radius was 2, and our height was 5. So that's 1/3 pi times 4 times 5. So if we do that on the calculator, that's approximately 20.94395102. And again, we're talking about volume in inches, so this is inches cubed. So now we know if we want this unique shape, we're going to have to subtract these to figure out what's left over, or in other words, what's remaining. So we are going to subtract them now here in this bottom section. So we're going to take the larger and subtract the smaller. Our larger volume was that 167.5516082. We're going to subtract the smaller volume, which was 20.94395102, which gives us approximately 146.6076572. Now, they wanted it to the nearest tenth. This is the tenths place, so we're going to look next to it. A 0 is not enough to bump us up. So we are going to stay at 146.6. And the volume, again, is what we're finding. So it's going to be inches cubed. And that concludes our lesson on multi-step volume problems.